All right, this is numbers 5 through 9, and I guess I've got also a few more to do 5 through 9 and 14 through 17. But I wanted to show the calculator. Yeah, granted, if you wanted to show x-axis symmetry, you would replace y with negative y and see if the original equation worked out to be the same as the new equation worked out to be the same as the new. If you wanted to show y-axis symmetry, you would place x with negative x, and then if you wanted to show origin symmetry, you'd have to replace x with negative x and y with negative y and see if the resulting equation was the original. But, let's just graph these and we can just look at it and see what the heck's going on. Be a lot more simplistic. All right, so what we've got here is, let's go to my y equals, let me clear this off, and type in 4x squared. Oh, nope, 4x squared. Let me clear this off and clear the whole thing off. 4x, there it is. There's the square term, and it's a subtract 4. And let me hit graph. And you got a parabola. You can see here, you've got y-axis symmetry. If I were to fold this along the y-axis, these points would lie right on top of those. Y-axis symmetry. Number 5, letter D, y-axis symmetry only right there. Now here, what you'd have to do is to solve for y. So how would I solve for y? I divide both sides by x. All right, so what would happen here? Here again, hopefully you can see it. Divide both sides by x. And I guess, no, I can't do that. I thought I could just write, no, that's going to highlight. Dividing both sides of this equation by x. The x would go away, and then I'd have this. Y would be equal to, clear this off, it'd be a negative 5. A negative 5, all right, divided by x. I want to get this solved for y so I can graph this. Divided by x. There it is. And let me graph this. And well, obviously you haven't got x-axis symmetry. These points don't show up here. You haven't got y-axis symmetry because these points don't show up on the other side here. What you have is symmetry to the origin. This point here, let's say, is 2, negative 2, and then you've got negative 2, positive 2. All right. Origin symmetry. Number 6, origin symmetry, letter B. All right, letter B, if I can clear this off. Which you should recognize with number 7. It's a circle whose center is at the origin. All right. Now with a circle, number 7, you've got x-axis symmetry, y-axis symmetry, and origin symmetry. All right. Recognize that this is now to graph this. I would have to get rid of the x squared term and take the square root of both sides. So it'd be something like this. Y would be equal to the square root. Let's see. It'd be the square root. All right. It'd be a negative x squared. I'd be subtracting x on both sides. So it'd be a negative x squared plus 9. And that would be the first part of the circle. The top part, if I would have graphed it, well, I got an error here. So what have I got? So that's the wrong side. That's the negative sign. All right, there's a better way of doing it. And what you get is the top half of the circle. Now, if I would do it, since I took the square root to solve for y, you have a negative here. All right, it'd be a negative. In fact, no, it'd be a minus sign here. Minus second function, the square root of negative x squared, negative x squared plus 9. And if I were to graph this, you get the bottom half. All right, so you could have recognized that this was a circle. I could have written this as x minus 0 quantity squared plus y minus 0 quantity squared, which meant my h and my k value were both 0. But when you see something like x squared plus y squared equals something, you got a circle whose center is at the origin. And the 9 represented the radius squared. You can see here the radius is 3. 1, 2, 3. All right, so circles symmetric to the x-axis, the y-axis, and the origin, the whole enchilada, letter D. And number 8 here. Okay, if I go here and I clear this off, it'd be much easier if you recognize this as a circle. You could have solved that. Most people get the top half, not the bottom half, because when you take the square root of y squared, it's plus or minus. Numbers have two square roots, a positive and a negative. So in parentheses, what have I got here? X minus 9 times quantity x plus 9, x plus 9, x plus 9, and hit graph. All right, you're not seeing everything here. All right, but what you've got is a parabola. Watch what I'm going to do here. I'm going to go to zoom, and I'm going to come down to something called zoom fit. All right. What that's going to do for me is give me the whole graph. And what I've got is a parabola here, all right, whose vertex is way down here at negative 81. How do I know that? Minus 9 times positive 9, all right. So this parabola is symmetric to the y-axis. If I fold this over the y-axis, these points would lie right on top of those, or those would lie right on top of these here. You've got y-axis symmetry for number 8, and that is letter A. All right, we haven't done absolute values, which you're going to see in a moment. I'll do this. Let me clear this off. So I want the absolute value symbol. All right, so I want to go to math. I want to go over the number, and the very first option, ABS, absolute, stands for absolute value. And what's inside the absolute? 17x. And I'll get out of that, and I'll hit graph. And, well, I need to go back to my original dimensions of my graph. So I'm going to go to zoom and come to now to number 6. Zoom standard puts it back to minus 10, positive 10. All right, you can't see all this here, but it's a parabola. I'm sorry, it's V-shaped. In fact, let me do this here. Let me make my window a little smaller. You make this from negative 5. You make this from negative 5 to positive 5. And the same thing on the y-axis, negative 5. Notice I'm using a negative sign, not the subtract sign, to positive 5. So let me do positive 5. The min minus 5 and the maximum positive 5. All right. Get a little better picture of what's going on. Yes and no. You got a V-shaped. All right, it's symmetric to the y-axis. If I were to fold this over, these points would lie over here and the other points on the other. In fact, let me do a zoom fit. See if I get a better representation of this. Yeah, much better. Okay, you can see symmetric to the y-axis. If I were to fold the graph right on the y-axis, these points would lie on top of these, or those on top of those. Definite y-axis. So that's number 9, and we've got dy axis only. All right, so let me see if I can come down to the rest of these. All right, odd, even, or neither. All right, we'll have an odd function if it's symmetric to the origin. Even function if it's symmetric to the x-axis. If it's symmetric to the y-axis, it's not even a function, so there's no need of talking about odd or even. We go back to zoom standard number 6 here. Get my graph looking like it's supposed to. This guy seems to be acting up on me. We quit. Second function. Let me just shut this guy off. Turn it back on. It likes that a lot better. Let me clear this. Sometimes it just doesn't want to cooperate, but we stay with it. So, number 14, 5x squared, 5x squared minus 1. All right, so hitting graph, and you realize you got a parabola. All right, so obviously symmetric to the y-axis here, because if I fold it, these points lie on. You get the idea, y-axis symmetry. So number 14, y-axis symmetry. What do we got? Well, it's even. All right. It's an even function. I'm sorry. Yeah, you got y-axis symmetry. X-axis symmetry would be nothing. Y-axis symmetry even. I may have said it just the way. I may have said it just the opposite. Misspoke. Y-axis symmetry. You've got even function. Origin symmetry. It's odd. All right. Y-axis number A. Even function. And what do we got here? A real mess. I guess I know. Y equals, clear this off, a negative 0.72 x squared. Why they're putting in that plus the absolute value of x plus. We go to my math function, go to number. First one is absolute value of x. Come out of this, and I want to add 5. And I want to be able to graph this. Yeah. And you see you've got symmetry to the y-axis here. This is what, number 15. Number 15. It's symmetric to the y-axis here. These points lie on top of these. If I folded along the y-axis, those would lie on top of that. All right, so it's an even function. Y-axis symmetry, even function. Number 15. Number 15, letter A. Clear this off, and what do we got? Number 16. So y, clear this off, and what do we got? X, got it, plus 5 over x, 5 divided by x. Hit your graph key. And of course, we don't have y-axis symmetry because these points aren't reflected there, and these aren't there. We haven't got x because these points aren't down bottom, and these aren't there. But you have origin symmetry, all right? Let's say this point is 2, 4. Then you've got -2, -4. These 2 points are reflections of one another. So origin symmetry, so you've got an odd function. Number 16, letter B, odd function. Origin symmetry. Clear this off. 14. Number 17 is 14. Get back here. Come on back here. 14 divided by x squared. And graphing this, and once again, you see what's going on here. 14, yeah, symmetric to the y-axis, all right? If I were to fold this on the y-axis, these points would lie right on top of those, or vice versa. The points in the second quadrant would overlap these points here. Y-axis symmetry means you've got an even function. Number 17 is letter A. And that should be that. Hopefully that helps.